So let's run through this, make sure everybody's got all these operations under control. No need for our phones, we gotta put our phones away. We are gonna get busy here. So number one says solve. Notice it doesn't tell you how to solve. So that means you get to pick. So what are your options? Elimination or substitution. You'll do whatever you want to do, okay? The quiz won't tell you, you'll get to choose. So, who's got a thought here? Gio?
Times the bottom by 2.
Times the bottom by 2, so he's going to eliminate. If we times the bottom by 2, the top stays the same, and then the bottom is 10x plus 2y equals 28. Remember, if you're going to times something by something, in this case multiply the bottom by 2, you have to do the whole thing. Okay? Now, when I add these, those are gone. That's why he did it, to eliminate those. So 13x equals 39, so x equals 3. Your answer is going to be an ordered pair. So we're going to go back to the beginning somewhere, it doesn't matter where, and we're going to plug in 3 for our x. So if I just do it on the top, I have 9 minus 2y equals 11. So I'll subtract 9, so negative 2y equals 2. I think y is negative 1. And that's that. All right, everybody okay? Substitution or elimination. All right, now number 2 is just a whole bunch of problems that have to do with our various matrices. So A has a little b. That means we are to be looking in matrix B. So here's matrix B. And this means what? What is this? This tells me where to look. This says look in the second row for the first column, first number. So in the second row, rows go this way. So in the second row, here's the second row, the first number is 2. So that's the entry that's in the second row, first column. What are the dimensions of matrix A? Gio? 2 by 3. Remember, the dimensions are how many of these do you have? And how many of these do you have? So it's rows, 2 of them, columns 3. So you write 2 by 3. That's how you write the dimensions, 2 by 3. All right, A plus C. Look at that carefully. Gio? Can't do it. Why can't we add A and C together? A is a 2 by 3 and C is a 2 by 2. And what is the rule for addition? They gotta match, right? And subtraction, addition and subtraction, they gotta match. So, no good for that one. So C is a no solution. Now D means multiply, okay? So we are going to see if we can multiply A. What are the dimensions of A? You said it was 2 by 3. And what are the dimensions of B? 3 by 3. Can those be multiplied? Yep, so here we go. A is this. And when we figure out that we can multiply, we also figure out how big our answer is. because the inside two have to match. The outside two tell me how big the answer is. So the answer is gonna have 2 rows and 3 columns. So all those little boxes have to be filled in with numbers. To get the numbers, let's just say this one right here. That is in row 1, column 1. So I'm gonna take the numbers in my first row and I'm gonna multiply them by the numbers in my first column. So I write down my first row, and then next to those respectively, I write down my first column. Okay, now what do I do with all these numbers? Well, these get multiplied, right? And then all of it gets added up. So what does that end up equaling? -1 plus 2 plus 15. What is that? What is that? 16? Right there, 16. Now, it doesn't matter where you go next. I usually go here next. That's going to be the first row of numbers again, but this time times the second column. So I'm going to start with my -115, and this time I'm multiplying by 1, 0, -1. I got -6, did you? Remember, there's no pattern here, you just get random numbers, you just keep multiplying, okay. All right, and finally, I'm gonna take my first row again, that -115, but now I'm gonna multiply it, oh gosh, is that the same set of numbers? -115. What does that come out to be? 27. Then we go to the bottom row and do the same thing. Only now we'll be using the 302. So we're going to use it 3 times. We're going to use it for the first column, for the second column, and for the third column, the 302. So 302 times 1, 2, 3. 302 times 1, 0, -1. And 302 times -115. See how there's just kind of a routine here? I mean, or I don't know what to say, pattern kind of like process you just keep repeating. All right, so what do we get? 9. 1 and 7. How do those look? Check my arithmetic. Speak up. I make mistakes a lot with my arithmetic.
7 looks right.
Looks right? Okay, so next we're going to find the determinant of A. Now, I know I mentioned this to you, but there weren't any problems, I don't think, like it in your notes. You can't find the determinant unless the matrix is square. So if we look at matrix A, is it square? So therefore the answer to E is can't do, or no solution, or empty set, or something. The only way you can find a determinant is if the matrix is square. So if they're asking you to do it with a not square, it's no solution. You can't do it. Now, we can do B, because B is square. B is a 3 by 3. Who remembers how how we find the determinant of a 3 by 3. What is the process we go through? Gio?
The first column and then put on the other side.
We take these two columns, the first two, we cut them out, and we paste them right here. And when we started this problem, I saw Edgeny going back through her notes. Perfect. That's why we take notes, guys, so we can go back and look at our process. Make sure you're taking good, careful notes. Okay, so we copy these down, paste them right here. All right, then what happens? Gio?
We multiply them diagonally.
Yes, so we start right here. Always start with this. And we multiply these together and get 0. And then we multiply those together and get 3. And we multiply those together and get 2. So I did 3 sets of multiplication. What do I do with all those numbers now? Add them up. So that total is 5. Now what? Same thing other way. So multiply 0. Remember, anytime you're multiplying by 0, you get 0. That's just a 0. This is going to be -1, and this is going to be 10. And you total those up and get 9. Then how do we get our final answer? We got all of these added up to 5, all of these added up to 9. Now we subtract. So 5 minus 9, that's your answer. Your answer is -4. Remember, the determinant is a number, a single number. It's not like a whole bunch of numbers, it's a single number. All right, and finally, we're finding the inverse of matrix C. All right, so this is a couple of steps. How do we find the inverse of a matrix? Who remembers? All right, so there's 2 steps to it, and the order you do the steps doesn't matter. So Edgeny is saying I'm going to build a new matrix. And the new matrix I build, I take these 2 numbers and switch their spots. And then these guys, I change their signs. So he's negative, he becomes positive. He's negative, he becomes positive. There's my new matrix. Okay, but that's only half the problem. What's the other half? What else do I have to do? Find the determinant. So how do you find the determinant? Here's my original matrix. How do you find the determinant of a small one like this? That's how you do a big one. How do you do a small one? You multiply, always start here, so you multiply, that gives us 3. Multiply, that gives us 5. And then what do we do with those 2 numbers? Same thing you did down here. What do you do with those 2 numbers? Subtract. So that gives us -2. Now what do I do with the -2? Take my new matrix that we built already and divide everything by -2. And that is going to be your inverse. So -3/2, -1/2, -5/2, -1/2. Nothing simplified here. Usually something will simplify. So you always want to make sure when you write your final answer that you've simplified your fractions or whatever. Okay? So what happens next time? We have a quiz. What does it look like? This. Let's see. Practice that on your own. If you wish. Okay, now we have 2 things to do today. One of them is total use of the calculator, and one of them is a new method of solving systems called Kramer's rule. So first, we're gonna use our calculator. Everybody needs to have a graphing calculator. If you don't have one, you're going to have to rent one, which means your name's gonna go on the board, which means at some point, you're gonna get a 0 on something, because you have a fine to pay, and you haven't paid it. You need to have a calculator. Hopefully, we all have one. Get it out. Make sure it's ready to go. You don't have one? You need a graphic calculator, guys, because I tell you what, if you have to do these problems by hand, which they're all doable by hand, it's gonna take you a long, long, long time. Long time. You got a calculator, Jocelyn? All right, so here we go. We're gonna do problem 7.3, number 1. We're gonna use our calculator to solve. This is a bigger system of equations. The one we practiced on the quiz, or on the practice quiz, where we had to do substitution or elimination. This is a bigger form of that problem. You can do substitution and elimination on this. It just takes okay, so here's what we're gonna do. We're gonna make a matrix out of all the numbers, just the numbers in the problem. So the numbers in the top row are 1, 1, -1, and 2. Does everybody see that? There's a 1, 1, -1, 2 in the top row. And we're gonna do the same thing for the second row. 2, -1, 3, 14. You write down every number in the row, including negatives. 3, 1, 1, 14. Now, please keep in mind that if there's like here is a plain y, that's a 1y, right? That's not a 0, that's a 1y, and this is a 1z. What are the dimensions of that matrix? 3 by 4. Keep that in mind. We're gonna need that here in a minute. So we're gonna go to our calculator. Everybody's gonna be typing along with me, right? So, if you look in your first column of buttons, right under your math button, you see matrix, the word matrix written there? Everybody see it? That's your matrix menu. So we're gonna go to second matrix. And you should have a list of names, A, B, C, D, and I don't know what all it says next to that, none of it really matters. First thing, I want you to click over across the top to where it says edit and hit enter. Now, the first thing the calculator wants to know is how big a matrix are you going to be putting in? So you just hit 3, enter, 4, enter. You are telling it you're going to feed it a 3 by 4 matrix. So it should set up for you a matrix, right? Now, if somebody has used your calculator or you've used your calculator, there may already be numbers in there. Don't worry, you're just going to type right over them. Okay, then we start putting in our numbers. So 1, enter, then it moves across. So then we go to 1, enter, then -1, make sure you're using your negative button down here at the bottom. Enter, and 2, enter. Then it brings you down here, you type in that row. 2, -1. After you get the last number in, you need to check in downstairs.
There's no one down there when I went down.
Oh, you already went down to try to check in? Okay. Okay, after you get your last number in, this 14 right here, and you press enter. Everybody good? Okay, so then I want you to second quit. So second quit, right there next to each other, second quit. And then that takes you back to your home screen. Okay? Now, go back into matrix, so second matrix. But this time, we're not going over to edit. We always go to edit first, because that's how we put the numbers in. Now we're going over to math, because we're gonna do something with this matrix, okay? Now, there's a whole list of stuff. I want you to just arrow down, just keep arrowing down until you get to the one that says RREF. So keep going. There's one that says REF. Don't stop there. Go to the next one. RREF. RREF stands for Reduced Row Echelon Form. And you're going to see what that is in a minute after you press that button. So go ahead and press that. RREF. Then go back into matrix, second matrix, and hit enter. So your screen should say RREFA. Press enter, and you're going to get a new matrix out that looks like this. It is in row echelon form, reduced row echelon form. It looks like that. We're gonna go through these steps again. I'm not gonna back up. We're gonna just keep plowing ahead. Now, this matrix gives you the answer to the problem. Remember when you built it originally? This was 1x plus 1y minus 1z equals 2. What does this say? 1x, no y's, no z's, equals 4. So x equals 4. What does y equal? 0. And what does z equal? 2. There's the answer to the system of equations. X is 4, y is 0, and z is 2. All right, let's try the next one. We're going to do exactly the same thing. So in terms of work, there really isn't any. So what do you need to write down? Well, all you need to write down is the matrix that you put in. So for problem 2, the matrix that I put in will be 1, 4, negative 2, 0, 2, 1, 1, 6, negative 3, 3, negative 5, negative 13. So write that matrix down. That's the matrix that you're going to put in. We're going to RREF it, and out's going to come the answer. That's all you have to write down. We're going to write down our matrix that goes in and our matrix that goes out, and that's going to give me my answer. Okay, so let's go back through those steps real carefully of how to make this happen. So first we go to second matrix and go all the way across to edit. Hit enter. First thing it wants to know is how big a matrix are we putting in? Well, is this another 3 by 4? So we're going to press 3, enter, 4, enter. So we're putting in a 3 by 4. Then we're just gonna type in all these numbers right on top of the other ones. Don't be confused, just type in the new ones. So 1, 4, -2, 0. As soon as we get all those in, press enter for that last one, -13, enter. Make sure it's set in there. And anybody remember what we do? Second quit. We gotta get out of there. We're done editing now. We're done putting stuff in, so second quit, just get out. Now go back in, second matrix. But now we don't wanna edit, now we wanna go over to math. And then arrow down to find the button that says RREF. Press enter. And then one more time, second matrix, enter. And then enter again. Did you get a matrix that looks like this? Did you get a matrix that looks like that?
Yep.
And when it's in reduced to echelon form, it literally says x equals 3, y equals -0.5, and z equals 0.5. There's your answer. That's all there is to it. All right, let's look at number 3. We'll walk through this one again very carefully to make sure everybody's getting it. The top row is pretty easy. 1, -1, 1, 0. Everybody good with that? But what about that second row? What's happening in that second row? Geo?
There's 0 Y's.
There's no Y's. So that's when we put a 0 in, okay? So we have 2 X's, 0 Y's, -3 Z's, and -1. It is really important that you have your X's, Y's, and Z's all lined up. So that 0 has to go in the Y spot. And then our bottom row is -1, -1, 2, and -1. Okay, if you know how to do this, you can ignore me and just go ahead and do it. If you don't know how to do it, we're gonna walk through this one again together. So second matrix. Click over to edit in the top row there and hit enter. Once again, we have a 3 by 4, so we hit 3, enter, 4, enter. That sets up our matrix, and we start typing in these numbers. So you type the number and hit enter. Sounds goofy, but make sure you're using your negative button down here. The subtraction sign is going to give you an error message. You need this down here. So after you type in that last -1, you press enter, and then second click. We're done editing. So we're telling the calculator, I'm done. It's all in there. Then back into matrix, so second matrix, top row over to math, down to RREF, enter. Back into second matrix one more time, enter. And that should give you your answer. And this time I got 1, 2, 1. Did anybody else get that? Hopefully. Okay. All right. good. So are you ready to try one on your own? Now, number 4 is a tricky one because why? What do you notice about number 4?
Four values.
Yeah. You've got 4 variables. So when you set this up, guys, you had x's, y's, z's equal a number, right? That's the way you put it in. So we're going to do that for number 4, except we're going to have not only x, y, and z spaces, but we're going to have w spaces. All right? So the top row will be 1, 1, -1, 0, 4. I have an x, a y, and a z. I do not have a w in my top equation. Would you agree with me? Now, what do I have in my second equation? I have a y, and I have a w, and I have a -4, but I do not have an x, and I do not have a z. Gio?
I did W, X, Y, Z.
Perfect. Absolutely perfect. Beautiful.
Doesn't matter.
Doesn't matter. It's going to matter when I write my final answer, because when I write my final answer, you will have a W, X, Y, Z, and I will have X, Y, Z, W. But it's fine either way as long as we label it. Okay? Perfect. All right, so what's my third row going to look like? I have an X, I have a -y, and I have a 1, but I have no Z and no W. And then finally on the bottom, I have an X, and a Z and a W, and a 1, but no Y. Now, if you lined up your variables like Geo did, or maybe your own special way, your matrix isn't going to look like this, but your answer will be exactly the same as mine. Okay? What are these dimensions? First thing I do is second matrix, over to edit, and it wants to know how big it is. How big is this guy? He's a 1, 2, 3, 4 by 1, 2, 3, 4, 5. So 4 by 5. As soon as you get your last number in, you're going to second quit, go back in, over to math, down to RREF, second matrix one more time. Now, what came out of mine, the way that I put stuff in, is this. Which means that X is 4.5. So if I line them up in the order Geo did, and start with W, I can do that. That keeps them alphabetical. That's a good idea. I got -7.5 for my W. Is that what you got? Yep, doesn't matter what order, we'll just do it alphabetically. So X is 4.5, Y is 3.5, and Z is 4. Now, if you wrote them in this order and labeled them X, Y, Z, W, that would be fine too. All right, one more all by yourself. Do that last problem all by yourself. Make sure you're writing down the matrix you put in, and the matrix that comes out, and the button you press to make it all happen. got a little wild and wacky with this problem. Do you see that your final matrix looks a little different than the other ones have looked? The other ones said things like X, no Y, Z's or W's equals 4.5. I'd like you to look at this bottom row for a minute. Remember, I think these were X, Y's, and Z's. What does that bottom row say? Literally, what does it say? Geo? What it says is no X's plus no Y's plus no Z's add up to 1. Can that happen? Can you have 0 of things adding up to 1? No. This problem has no solution. Do you remember sometimes when we did substitution and elimination by hand, we got no solution sometimes? This is 0 equals 1. Not true. Now what does that mean? Well, if they're lines, it means they're parallel. These aren't lines. These XYZ things are planes. Like the ceiling is an equation, XYZ, and the wall, XYZ. And what's happening is these 3 planes in this problem are not intersecting in a single point. If they intersect in a single point, it's like the corner of the room. But if they don't intersect in a single point, it's like having this plane and the ceiling and this plane. They don't all intersect all together. So that's what happened here. We got no solution to that problem. And what was the clue? Right here. That was your clue. Okay? All right, next, last thing we have to do today is Kramer's rule. So let's look at the next page. And we aren't going to use a calculator for this. We are going to learn a new method, which some people really, really like. So if you really like it and get it, you can use it on your quiz tomorrow, because doesn't that look like a quiz question? You could eliminate with that, you could substitute with that. We're going to use Kramer's rule. Step 1, find the determinant of the coefficients. So the coefficients are the X and Y numbers. So 2, 3, 3, negative 4. We're going to evaluate that determinant. Okay? So what is that determinant? This is good quiz practice for tomorrow. What's this determinant? Negative 8, 9, and subtract them? So negative 17. All right, just hang on to that number for a second. Now you're going to find 2 more determinants. We're solving for X and Y. We ultimately want to know what are the X and the Y. To get X, you build another determinant. Only you take the 1 and 2, these guys right here, and you paste them on top of the X numbers. In the original determinant, these were the X's and these were the Y's. Take the 1 and the 2 and paste them here. So 1, 2, and then 3, negative 4 stays there. So cut these out, these numbers, and put them here in the X spot. Then to do the Y variable, you do the same thing, only you cut out the 1 and 2 and paste them on the y spot. So whatever letter you're solving for, that's where you paste it. Okay? So 2, 3, 1, 2. Now let's evaluate these. So what do we get here? -4 minus 6, -10. And then 4 minus 3, 1. The answer to the question is -10 over -17 and 1 over -17. So remember when we found that coefficient determinant first? That becomes the denominator of your fractions. It's kind of like when we did the inverse of a matrix. The determinant, the original determinant, becomes the denominator. So my answer is 10/17, comma, 1 over -17. Now that's an awful answer. I mean, that's not a very good answer at all. But did I really have to do any work with fractions? No, they came out, but I didn't have to do any work. If I use substitution or elimination, you're gonna have to deal with fractions. So a lot of times Cramer's rule is actually easier because you don't have to deal with the fractions. Let's try the next one. All right, so what's step 1? Step 1 is what? Find a determinant of just the x's and y's, the coefficients. So 1, 1, 2, -1, 1, 1, 2, -1. Just start there. What does that equal? -1 minus 2, -3. Now whatever our answer works out to be, that's going to be the denominator of my answer, that -3. Now, to find the numerators, I have to make 2 new determinants. Who was paying attention? How do I find the new determinants? Brennan?
You have to replace 7, 8 over the x's.
Exactly. If you're doing x, the 7 and 8 replace the x numbers, right? So the 7 and 8 are gonna go here. These are the x numbers, these are the y numbers. So I'm putting the 7 and the 8 here and leave the 1, -1. Now notice I'm not switching anything around. I'm cutting these out and pasting them on top of the x numbers. Then I'm gonna cut them out and paste them on top of the y numbers. Then I'm going to evaluate those. So this one is going to be -7 minus 8. Did you get -15? And that's the numerator for x. 8 minus 14, I got -6 for that one. And that's the numerator for y. So just like with your inverse, you simplify if you can. So what's my answer?
15 over 3, 6 over 3.
And what's 15 over 3? 5. And 6 over 3 is 2. So your answer is 5, 2. If you did substitution or elimination with this, that's what you get. That's exactly what you get. And any method is fine. All right, let's try C. See how far you can get on your own. Do you remember how to start? Remember that you need to build the coefficient determinant. So 3, 4, 1, 2. By the way, These things have to be lined up. It's like with elimination, they gotta be in the right order. Anybody get a value for that? 10? That's what I got. 6 minus -4. Remember, you subtract them. So you got a 6 and a -4, but you're subtracting, so it becomes 10. Okay, anybody remember how we find our x numerator? Take the 9 and the 2 and plug them in for x. So 9, 2, -4, 2. And then take the 9, 2 and plug them in for y. So 3, 1, 9, 2. All right, that should give me my, oops, 2. That should give me my answer for 10. What do we have? Did you get 26 for x? Remember, it's a subtraction. 18 minus -8. And did you get -3 for what? So our answer is 13/5, comma, -3/10. Again, you can do substitution or elimination with this guy, but you're gonna have to deal with these fractions. So a lot of times Kramer's rule is just easier. All right, last one, all by yourselves. Last one of the day. So let's see what we can come up with. So there's what I came up with. See if we match on anything. Hopefully everything, but see if we match on anything. Match. Get these hideous numbers here. Anybody have a question about where one of those numbers came from? Brendan?
Just a question on the is that negative because all of them
So it's 2 minus -21. Yeah, it's very easy to make arithmetic mistakes. You have to be real careful.